Today, we're going to learn how to factor out the greatest common factor, also known as the GCF, out of some examples of polynomials. Here, we have a binomial since there are two terms. We want to come up with what common number goes into 7 and 21. Thinking about this, the different factors are 7 are really only 1 and 7. As for 21, we know the number 1, 3, 7, and 21 are divisible by it. The highest common number within these is 7. This means when we rewrite our two terms, we can pull out a number 7 out of both of them. And when I say pull out, we're really dividing that number out of both terms. When we divide out our 7, we want to write down what we have left. So here, we know we have x cubed times y. That's all one term that's left after we divide the 7 out of it and put it in front. And then we take our 21xy, divide out the 7, and we're left with a 3xy, all one term again. Now, when you've learned about the greatest common factor before, you've only worked with numbers. Since we're working with different polynomials, we might have to pull out the GCF, not just of numbers, but also of different variables. Here, we can see in our first term that there's an x cubed. So we know that's really x times x times x. In our second term, we only have an x to the first, which means we just have an x. The highest common amount of values of x between these two terms is just x to the first. This means not only are we going to have 7 as our GCF pulled out front of our two terms, but we're also going to have an x. When we take one x from each of the terms, we want to write down what we have left. Here, we'll have x to the second, since there are two x's being multiplied together that are left, as well as our y in our first term. And then in our second term, we're going to have 3y left, since we already pulled out that x to the first that was there. Lastly, we want to see what other variables are in common between our two terms. Here, we can see that there's a y to the first, and also another y to the first in our second term as well. This means we can also pull out that y to the front as one of our GCFs, along with our x to the first, and along with our already pulled out 7. So we can rewrite what we have left as x squared plus 3. Therefore, we were able to change our original binomial at the top and rewrite it by pulling out the GCF as this answered form. So our new way to write this problem is 7xy times x squared plus 3. This is the factored form we are looking for. Now, when we were factoring trinomials before, we could use either the FOIL method or the distributive method to figure out if our newly factored form could go back to its original form. We saw that if we could change it back into its original form, then we came up with the right factored form. We called this checking, so we're going to go ahead and check our new answer to see if we can multiply our 7xy back into x squared plus 3 to get our original answer. So let's do our check. And we're going to see if when we multiply 7xy times x squared plus 3, if we get our original problem. So really, the only way we can do this is through distributive, since we don't have two binomials for FOIL. So we know 7 times 1, 7, x to the first times x squared gives us x to the third, and then we have the y on the end, or y to the first. When I go ahead and multiply 7xy times my value of 3, I end up getting plus 21xy. And we can see that this result does match our original problem. Therefore, we know our factored form is correctly factored with the GCF.